So here's 8a, which is 2 to the third times 2 to the seventh squared. And there's a couple different ways you could do this. You could either think of it as 2 to the third times 2 to the seventh, so 2 to the 3 plus 7 squared, which is 2 to the 10th squared, which is 2 to the 10 times 2, which is 2 to the 20th. That's a perfectly fine way to get there. You can also think of it as 2 to the third squared times 2 to the 7th squared, and then that's 2 to the 6th times 2 to the 14th, which is 2 to the 20th. There's probably like 3 other good ways you could imagine if you wanted to. Again, as long as you can make it work and you're thinking about things in a correct way, I don't particularly care if it's the way I have thought of it, as long as it's correct. Let's look at the next one. 5 to the 5th divided by 5 to the 9th. So that's going to be, you can either write it as 5 to the negative 4th or 1 over 5 to the 4th. I think the problem specifically says you're encouraged to leave your answer as a base to a power. If that was my reading of that, is this would be the preferred way of writing it, as it's a base to a power. It's not 1 over. So that's a good question. What if you wrote it as 1 over 625? I probably wouldn't mark you off, but I would just point out that the instructions really are encouraging you to write it as a base to a power. So if I were, well, if I hadn't already written the final, if I were writing a new final, I'd probably make it so the powers were a little bit larger in the end so that it would be less easy to write it as actually the simplified result. But yeah, 1 over 625 would also be acceptable. Let's look at the last one here. X squared times x to the 4th to the 3rd divided by x to the 7th. So one option, which I'm not going to take, would be to say it was x squared cubed times x to the 4th cubed. But if those things have the same base, it does make more sense usually to kind of combine them first. So my first step here would be to write this as x to the 6th to the 3rd, x to the 7th, right? Just multiplying those together by adding their powers. And then x to the 6th to the 3rd is a power to a power. We're going to multiply the powers and get x to the 18th divided by x to the 7th. And then in the notes, as I sent you guys an email yesterday, I did make a mistake on this in the practice time of solutions. I accidentally wrote this as x to the 18th minus 11 and got x to the 7th. I think I was thinking of the answer ahead of time. This should be just x to the 18 minus 7, which is x to the 11. So that was not an easy mistake, just sometimes you read the wrong thing, or you think the wrong thing, you think the right thing. Always a good reminder to be careful when you're showing your work. Let's look at the next problem, problem 9a. I would also, something I haven't said a whole lot in class, which I should have said maybe more often, is when you're taking an exam or doing your homework, I really, really encourage you to carefully read the instructions. And sometimes, especially like in Calc 2, for example, the instruction might say something like, set up the integral for this thing and don't solve it. And then at least 25% of the students spend time solving it because they didn't read the instructions. And you're not going to really get any extra points for that because it's not what was assigned. So just an important reminder here in general, read the instructions and don't spend time doing more than what's asked for because you're typically not going to get any extra points for that. So the following question says, solve the following equations either by factoring or using the quadratic equation. Note, you can only use the quadratic equation when solving ax squared plus bx plus c equals 0. Oh, nice. Okay. So we've got x cubed plus 25x equal to 10x squared. Yeah. So as is typical with any non-linear equation, we typically want to bring everything over to the left-hand side. And it's non-linear if you see powers of x other than 1, which we definitely do. So x cubed minus 10x squared plus 25x equals 0. And we are typically going to factor if we can. And so when you're factoring something, you always should look for a greatest common factor before you look for like the usual kind of two things multiplied together that you would FOIL out. And here we're going to look for, well, I see an x as a common factor. So I have x times x squared minus 10x plus 25 equal to 0. And then I see if I can factor this more. Oh yeah, there are definitely two numbers that multiply to 25 and add to negative 10. They're negative 5 and negative 5. So the factor is x times x minus 5 times x minus 5. Or if you prefer, x times x minus 5 ln b squared. So my two solutions are x equal to 0 and x equal to 5. I'll just point out, I've seen people, lots of people over the years, be really good at factoring like something, you know, like x squared minus 5x minus 24 equal to 0. They're like, oh yeah, I know how to multiply the negative 24 and add to negative 5. And it's, you know, x minus 8 times x plus 3. I've seen people be really good at this and struggle with something like this, x squared plus 6x equal to 0. And the problem is when people are doing this, they're looking for the more complicated factoring. They're like, oh, what do I want two things that multiply and add up. Well, here's the thing, before you look for that more complicated factoring, look for a greatest common factor. Oh yeah, x squared plus 6x both have a factor of x. And this one is actually just super easy if we think about that first. So you do end up getting x equal to 0 or x equal to negative 6. So just be careful, right? Don't make things overly complicated if you can help it. Let's look at the next one. Uh, 2x cubed plus 6x equal to 3x squared plus 9. And I will just say in general, if you see an even number of terms in the thing you want to try and factor or solve for, it's a good bet you might try factoring by grouping. So I'm going to bring everything to the left, and I'm typically going to write it in the decreasing order. So 2x cubed minus 3x squared plus 6x minus 9. And then from this to, I'm going to factor out an x squared. I'm left with a 2x minus 3. From these, I'm going to factor out a positive 3. I'm left with a 2x minus 3. And then to be able to go any further, the leftovers here have to be the same as the leftovers here. So just as a point, just to kind of show something different, right? If this had instead been 2x cubed, what do I want here? Minus 3x squared minus 6x plus 9. Like if that had been what we were starting with instead, and I did the same sort of thing, I factor out an x squared here, get a 2x minus 3. I really would need to factor out a negative 3 here, so that the remaining part is a positive 2x and a minus 3. If you factor out a positive 3, which seems like the more kind of maybe natural thing to first think of, factor out a positive 3, you have to have a negative 2x here and a positive 3 here, and those aren't the same. So then you have to do more work. You say, oh, I really need to also factor out a negative 1, and then I'm left with a 2x minus 3, and those match. So as long as this and this match, we can continue on to the next step. So then we factor that out from each of them. So you're left with a 2x minus 3 times an x squared plus 3 equal to 0. In this case, we're only going to get one real solution. Right? If we set this equal to 0, we get 2x equal to 3, we get x equal to 3 halves. If we set this equal to 0, we get no real solutions because we end up with x squared equal to negative 3. And we know that there aren't any real numbers that when you square them, they are negative. So we're done. That's it. There's no solution. So our only solution is x equal to 3 halves. That kind of hurt. Snap the board a little harder than I meant to there. All right. Let us look at the last one on this. There's no solution. No. So no solution. So that's an excellent question. If you have at least one real solution, then you never also want to say that there are no solutions. But if your original equation was something like, I don't know, x squared, let me think for a minute here, plus x plus 2 equal to 0. If that was your original equation, and you were getting, and so you use the quadratic equation, and you got x equal to -1 plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2. This one, there would be no real solution because 1 minus 8 is -7, and square root of negative is not real. So this equation, we would say, has no solutions, or if you want to be more specific, no real solutions. So in this case, that's the only thing we can say, there are no real solutions. Whereas here, it's not true that there are no solutions. X equal to positive 3/2 is a solution, and this other part of it just doesn't have any additional solutions. When is the final due, and is there a time limit? The final is due tonight at 11:59 p.m. There is a time limit of 3 hours. You can also turn it in late by up to tomorrow at noon. I would prefer to return in today so that I can get started grading. I mean, I can still start grading even if some of you don't turn in, but I would prefer you all turn in so I can start grading it first thing tomorrow morning so I can get it graded before the end of the day so that you can all have your grades for the class, which will be pass or no pass. Yeah. So yes, if there is a no solution and a real solution, we just say that the solution is the real solution. There is no penalty for being late. I will point out that that might not be, probably won't be true in future classes. So, right, again, as I mentioned, I've been very lenient, as that is just the kind of person I am. I warn you not to expect that from other people in the future. So definitely, I encourage you all to try to be as prompt and with turning in your assignments for future classes, including mine. I'm usually pretty lax over the summer. I'm going to teach pre-16 next quarter. If you're taking it from me, I'm usually a little more stringent about people turning things in that time. And that's probably more so true being in person, which we will be in person, which still feels kind of weird, not gonna lie. No, I was not. That's an excellent question. I was so definitely. So I don't want to get too hold on. So someone asked me, was I as lenient in Colorado Springs? I definitely was not. There I was the instructor of record. I was teaching classes that were for letter grade. So I definitely was more strict because my role was different. I can talk more about that in office hours if you really want to know. So let's see this. So solve the following equations, which are quadratic forms. Oh, that feels really good. By either making a U substitution or by using the AC method and factoring by grouping. You do not need to check the results for extraneous solutions. Okay. So the first one is x to the 4th minus 7x squared plus 12. So we could do a U sub, or we could not. We could just say, I want to multiply it to 12 and add it to 7. Sorry, -7. It is important that we be aware of the signs. So I'm looking for -3 and -4. So we could totally do this as x to the 4th minus 3x squared minus 4x squared plus 12 equal to 0. And then we could factor by grouping. Pull out an x squared with x squared minus 3. Pull out a -4, so that we're left with the positive x squared behind. X squared minus 3. And then factoring out x squared minus 3, we have x squared minus 3 times x squared minus 4. How many real solutions are we going to get here? 0, 1, 2, 3, or 4? Yeah, we're going to get 4 because we have x squared minus 3 equal to 0, which gives us x squared equal to 3, which gives us x equal to plus or minus the square root of 3. And we also have x squared minus 4 equal to 0, which you could factor as x minus 2 times x plus 2, or you could do x squared equal to 4, x equal to plus or minus the square root of 4, which is x equal to plus or minus 2. 4 distinct solutions. Or you could do the U sub thing, right? You could say U is equal to x squared, U squared is equal to x to the 4th, and rewrite this as U squared minus 7U plus 12 equal to 0. And then you would have u minus 4 times u minus 3 equal to 0. So you get u equal to 4, which would mean x squared equal to 4.
Oh, yeah.
Or you have u equal to 3, which would mean x squared equal to 3. So same solutions either way, just a different way of getting there. All right, let's do the next one. X to the negative 2/3 plus x to the negative 1/3 minus 6 equals 0. This one I will do the other way, the u substitution way. So I'm going to let u equal x to the negative 1/3. U squared is going to be x to the negative 1/3 squared, and negative 1/3 times 2 is negative 2/3. So I end up with u squared plus u minus 6 equal to 0. And then we're going to factor. This factor is u plus 3 times u minus 2. So I end up getting either u equal to negative 3, u equal to positive 2. And then I'm going to replace u with x to the negative 1/3. So I have x to the negative 1/3 equals negative 3. To isolate or solve for x, we have to raise both sides to the power that is the reciprocal of the negative 1/3 power. So we're going to raise both sides to the negative 3rd power. So x to the negative 1/3 to the negative 3rd equals negative 3 to the negative 3rd. X to the negative 1/3 to the negative 3rd is x to the 1, which is just x. What is negative 3 to the negative 3rd? Well, it's going to be 1 over negative 3 to the positive 3rd. And negative 3 to the 3rd is negative 3 times negative 3 times negative 3, which is negative 27. So we're going to get 1 over negative 27. Or as I would probably prefer to write negative 1/27. And yes. Oh, excuse me, sorry about that. Yes, it's perfectly fine to have a negative number to an odd power. Thank you, appreciate it. Same deal here. X to the negative 1/3 equal to 2. We're going to raise both sides to the negative 3rd power. And we're going to get x equal to 2 to the negative 3rd, which is 1 over 2 to the 3rd, which is 1/8. Let's look at the next one. Some graphing. You said only works at even powers, x to the 5th wouldn't work. I'm not sure what you're referring to. Like it would work if you had something like x to the 10th minus 2x to the 5th minus 3 equal to 0. Then you could let u equal x to the 5th and u squared would be x to the 10th. That would totally work there. So graphing. We want to graph 4x plus 6y equals 12. If we see an equation like this, we should recognize. So the final can be found. So it's not under the. It's not in the modules. It's in the assignments. So we click on assignments and then scroll down. In fact, let me show you. Why don't I just do that instead? So let's go to assignments.
And assignments, if you scroll all the way down to the bottom, there's the final exam right there. And you click on the final exam and it should take you to the correct place in Gradescope. That's annoying. I wonder why it's not linked. Well, I'll fix that in a moment. He says he tries to do it right now. Sorry, now I'm like, this needs to work. I will have to look at that. So but you can also just go to Gradescope. If you go to Gradescope. Yeah, okay. I'm gonna have to fix that. Sorry about that. Yeah, I'll get that fixed right after class today, and then I will let you all know, because it definitely was working earlier. I'm a little confused as to why it's not. Okay, sorry. So yes, that's where you should be able to find it. But again, he might have issues. Exactly, you can access it at the Gradescope dashboard as well. So I'm going to graph this. It's a line. I'm going to find the intercepts. Y-intercept is x equal to 0. I'm going to get 0 plus 6y equal to 12. So y is going to equal to x-intercept. We're going to set y equal to 0. So we're going to get 4x equal to 12. X is going to be 3. So y is 2, x is 3. It's always something like that. There's my line. So graphing a line should be a really, really fast, straightforward process. Find the y-intercept, find the x-intercept, draw the line between them. Okay, let's look at the next one. Y equal to negative x squared minus 4x minus 5. Definitely parabola. Definitely opens downwards. Let's find the vertex. So the vertex, the x coordinate is going to be negative b over 2a, which is negative 4 over 2 times negative 1. So it's going to be 4 over negative 2 or negative 2. The y coordinate, we're just going to plug in negative. So be careful. We're plugging negative 2. It's going to be negative x squared minus 4 times x minus 5. And then plugging in negative 2 for x. So negative 2 squared is 4, and then it's negative 4. Minus 4 times minus 2 is plus 8. Minus 5. So negative 4 plus 8 is 4, minus 5 is negative 1. Interesting. Okay. So my y-intercept, on the other hand, set x equal to 0, you're going to get y equal to negative 5. So if I start graphing things, my vertex is over here at negative 2, negative 1. And my y-intercept is over here at negative 2, 3, 4, 5. And this opens downward, so I don't have an x-intercept. So when you graph this, you should go like that, and then I should hit the y-intercept and cross and go right over to the other side. No x-intercepts, don't bother trying to find them if there's no x-intercepts. Right, and I can see looking at this and thinking it might factor, it doesn't. Because if you factor out the minus sign, it's x squared plus 4x plus 5. And there's no way to multiply the positive 5 and add it to positive 4. That's it. If you wanted to, you could plot another point over here
at -4, -5. Okay. Let's look at the next one. Okay, we got time. All right, it's good. Just Sarah just messaged me and let us know that we're up to 94% vaccination on campus. It's good. We're getting there. Now I want to graph y equal to x minus 5 times x plus 1 squared. And the idea here is we're going to find the y-intercept, the x-intercepts, and the multiplicities of those x-intercepts to help us graph it. So let's do the y-intercept first. We're going to set x equal to 0. We're going to get y equal to 0 minus 5 times 0 plus 1 squared. That's going to be -5 times 1 squared, which is 1, and -5 times 1 is -5. So my y-intercept is 0, -5. My x-intercepts, I'm going to get by setting each factor equal to 0. So x minus 5 equal to 0 is going to give me x equal to 5. And x plus 1 squared equal to 0 is going to give me x equal to -1. And x equal to 5 is going to have a multiplicity of 1 because it came from this factor with a power of 1. X equal to -1 is going to have a multiplicity of 2 because it came from this factor that has a power of 2. And we know that for x equals 5, we're going to cross, as the multiplicity is odd. For x equal to -1, we're going to bounce, because the multiplicity is even. If you like, you can also make a sign chart. You can pick a number larger than 5, like 6. Plug it in and see that 6 minus 5 is positive. 6 plus 1 squared is positive, and positive times positive is positive. Pick a number between -1 and 5, like 0. 0 minus 5 is negative. 0 plus 1 squared is positive, and the negative times positive is negative. Pick a number less than -1, like -3. -3 minus 5 is negative. -3 plus 1 is negative, and the negative number squared is positive. So a negative times a positive is still negative. So the graph is going to be below the x-axis, bounce off and stay below, and then go hit 5 and cross through to be above. So I'm negative over here. I come up and I bounce off at -1 right there. And then I go down, and I don't know how far down I go here. I'm just going to make a choice and turn around somewhere, and then go back and hit and go through there. I'm going to make that look a little bit nicer. Your graph should be smooth. There shouldn't be any sharp turns or corners or anything like that. So there is one possibly correct answer for this question. But again, maybe you want to turn around sooner. I don't know. It's fine to do whatever you want as long as you have the features that we need. Yep, here we go. Look at the next one. Okay. Next one is y equal to x cubed times x plus 3 squared times x minus 2. So same idea. We're going to find the y-intercept. We plug in x equal to 0. We're going to get y equal to 0 cubed times. I really should just stop there because the rest of it's going to not matter. Because 0 to any power is 0, and 0 times anything else is still 0. And y-intercept is just 0. And x-intercepts, I have, right, I'm setting x cubed times x plus 3 squared times x minus 2 equal to 0. From this factor, I get x equal to 2. From this factor, I get x equal to -3. And from this factor, I do get x equal to 0. And the multiplicities are, the multiplicity here is 1. The multiplicity here is 2.
and the multiplicity here is 3. So I'm really just looking at the powers that the factors that the zeros came from. So let's see, I've got 0 as an x-intercept and as a y-intercept. I've got +2, got -3. Now this one I really would use a sign chart actually, because I don't really know anywhere from above or below. So I'd still make a sign chart with all of my x-intercepts on the sign chart. And then we're going to pick values that are not those values. So pick something larger than 2, like 3. Plugging in 3, the whole thing is positive times a positive times a positive. Now you can keep plugging in values, which is fine. If I plug in something between 0 and 2, like 1, I have a positive times a positive times a negative. Overall, it's negative. Or you could say, well, I know at 2, the multiplicity is 1, so it's going to cross. And I'm going to cross from being positive to being negative. So we're going to cross like this. Right? We cross at 2 from negative. And then at 0, 0 came from a factor with an odd multiplicity. Oh, I guess I could write things down here, right? We're going to cross at 2, we're going to cross at 0, we're going to bounce at -3. So you could say, oh, I'm going to cross at 0 like that. So I'm going to have to be positive here. Or you could pick a number like -1 and plug it in. And -1 cubed is negative, and -1 plus 3 squared is positive, and -1 minus 2 is negative. So it's a negative, it's a positive, it's a negative, which is positive. And then finally, at -3, you can do the same sort of thing. You pick something like -4. -4 cubed is negative. -4 plus 3 is negative, and -4 squared is positive. And -4 minus 2 is negative. So it's a negative, positive, negative. Overall, it's going to be positive. And that's where it's going to bounce off. Like that. So there's my sign chart. Positive, positive, negative, positive. And here's my graph. Someone wrote a thing. Never realized the number line is just the x-axis on the board. Yeah, that's totally true. That is an excellent observation. The number line is literally just the x-axis part of the coordinate plane, for sure. Good call. Yeah, it's a really good thing to know. Okay, graph the following exponential and logarithmic functions. Be sure to include any and all intercepts as well as any asymptotes. An exponential function should always have a horizontal asymptote, and your logarithmic function should always have a vertical asymptote. Look at me giving you all sorts of information. How kind. What a gentleman of a teacher. Okay. So, let's graph these. The first one is y equals 3 to the x plus 2. Again, as far as I'm concerned, you really only need to tell me the intercept and the asymptote. So the y-intercept, we're going to set x equal to 0. We're going to get y equal to 3 to the 0 plus 2, which is 1 plus 2, which is 3. The horizontal asymptote, usually for an exponential function, it would be y equal to 0, but it's going to shift it up 2. So it's going to be y equal to 0 plus 2, which is y equal to 2. So my horizontal asymptote is y equal to 2. And my graph is y equal to 3 to the x plus 2. It's going to have an intercept of 0, 3. And since my base is larger than 1, it's going to get bigger from left to right. It's going to do this kind of deal. And if you wanted another point, you could pick like x equal to 1 and get y equal to 3 to the 1 plus 2, which is 3 plus 2, which is 5. So you could pick another point here and be like, okay, there's 1, 5. If you really, really wanted another point. Not required. I suppose if you were actually plotting points and trying to make it look nicer, right, that probably wouldn't cut it. What I mean is, if I was actually like using the graph with a grid on it, I would need my 1, 5 point to be like right here, and my 0, 3 point to be right there. So that would force me to be a little bit more accurate, like that. But again, as long as you have the all the intercepts and the asymptotes, that's enough. So the next one, y equal to 2 to the x minus 4. Okay. Again, exponential, increasing from left to right because my base is larger than 1. My y-intercept is going to be, well, x is 0, y is going to be 2 to the 0 minus 4, which is 1 minus 4, which is negative 3. Which isn't surprising because it's your usual y-intercept of 1 shifted down 4, and 1 minus 4 is negative 3. My horizontal asymptote is going to be y equal to 0 minus 4. There's my horizontal asymptote of y equal to negative 4. Here is my y-intercept of 0, negative 3, and we graph it. So we can, before we graph it, we should make an observation. We can see that there's going to be an x-intercept because it's going to go up like this, so it's going to cross the x-axis. We might as well take the time to find the x-intercept before we actually graph it. So to find the x-intercept, we're going to set y equal to 0. So we have 2 to the x minus 4 equal to 0, or 2 to the x equal to 4. All right, 2 to what power equals 4? Oh, x has to be 2. Because 2 squared is equal to 4. So we can make this look relatively nice. Okay. Don't turn too hard, right? It shouldn't go straight up. It should look like the graph continues to the right and up, not just up. It can be sometimes challenging to make it look good. That looks like it's still going to the right and up. All right. Last 2 questions, some logarithmic graphs. So the first one is to graph y equal to log base 5 of x minus 3. That's going to take my usual logarithmic graph and it's going to shift it 3 to the right. So usually our graph would look like that, with an x-intercept of 1, 0. This is going to take everything and shift it 4 to the right. So instead of having, sorry, 3 to the right, not 4 to the right, apologies. So instead of having a vertical asymptote of x equal to 0, we're going to have a vertical asymptote of x equal to 3, which you can find by setting the insides equal to 0. X minus 3 equal to 0 gives us x equal to 3. The x-intercept, you can either say, well, it would have been 1, we shifted it 3 to the right, so 1 plus 3 is going to give us 4. Or you could show more work if you wanted to and say, well, I know that I get the x-intercept away. I always get the x-intercept by setting y equal to 0. We set y equal to 0, 0 equals log base 5 of x minus 3. So 5 to the 0th power equals x minus 3. And then you add 3 over here, 1, which is 5 to the 0, plus 3 equals x. So x equals 4. Either way is perfectly acceptable in my eyes. So 4. My new vertical asymptote is that x equals 3. My new x-intercept is that x equals 4. And it should look like this. So to the right, it should get bigger and bigger and bigger like that. And to the left, it should get more and more negative as the x values push it closer and closer to 3. All right, one more. Not surprisingly, it's going to be a shift to the left. Y equals to log base 16 of x plus 4. So this is going to shift it 4 to the left. Our vertical asymptote is going to be where x plus 4 is equal to 0, or if you prefer, x equal to negative 4. For most of the examples we've seen, our vertical asymptote and our x-intercept are always 1 away from each other. That's because we haven't done any real kind of stretching or scrunching. So it's a pretty safe bet that once you found the vertical asymptote, the x-intercept should be 1 to the right of it when you're talking about logarithmic graphs. But we can also show the work. X-intercept, we're going to set y equal to 0. We're going to get 0 equal to log base 16 of x plus 4. Or 16 to the 0th power equals x plus 4. That's 1. So 1 minus 4 equals x. Oh yeah, x is equal to negative 3. No big surprises there. We can also see there's going to be a y-intercept. So let's go ahead and find that before we graph things. So the y-intercept, we're going to set x equal to 0. So we're going to get y equal to log base 16 of 0 plus 4. Okay, so now we're asking the question, what's log base 16 of 4? Or in other words, 16 raised to what power equals 4? You guys have any guesses? Oh, you're very close. That's a good guess. I would say that's the answer to the reverse question. Log base 4 of 16 is equal to 2. Right, 1/2 is the power we're looking for, because 16 to the 1/2 power, also known as the square root of 16, right? 16 to the 1/2 power is equal to 4. And something worth knowing is if the argument is smaller than the base, the power needs to be smaller than 1. Whereas if the argument is bigger than the base, the power needs to be bigger than 1. Right? Because you need a bigger power to make this number larger. You need a power less than 1 to make that thing smaller. So yeah, so if you see something in the future like, I don't know, log base 125 of 5, like, oh, I need a power that's going to make 125 smaller, so I need a power that's smaller than 1. This is going to be a 1/3 power, because 125 to the 1/3 is 5. Or in other words, excuse me, the cube root of 125 is equal to 5. So our x-intercept is positive 1/2. And this is where I try not to be super precise, even though I'm drawing it precisely, because making this be negative 3 and this be 1/2 makes it really kind of hard to get the graph to look nice. Like it ends up looking kind of. You make sure you draw an arrow going down that way, an arrow going up into the right that way, so that it still continues on.